Welcome to Webinar Wednesday. On behalf of the Powder Coating Institute, thank you for joining us for today's webinar, Cost-Effective, Non-Destructive Methods to Clean Hooks and Racks, presented by Larry Ensley of Hubbard Hall. Before we get started, I would like to remind everyone that all attendees are on mute, so if you have any questions along the way, please type them in the questions panel. The speaker will address the questions at the end of the webinar. If we run out of time, contact information will be on the closing slide if you have any additional questions. This webinar will be recorded and available through the PCI store within 2 business days. All attendees will receive a brief survey after the webinar. Please take a few moments to reply. We appreciate your feedback as PCI continues to develop new programs to offer the topics and training you need. Now I'd like to introduce the presenter for today's webinar. Larry Ensley, Director of Technical Applications, is a graduate of North Greenville University and oversees Hubbard Hall's technical service team and lab operations. He has extensive experience in the chemical industry and has been with the organization for almost 30 years, successfully guiding his technical team. Larry is the active product manager for 2 major product lines within Hubbard Hall. I'd like to introduce Larry, so take it away.
Thank you, Kevin, and thank you everyone for attending today's webinar. Again, my name is Larry Ensley. I've got 29 years experience of trying to help people solve their problems using chemistry to effectively to make their processes better. We are going to be talking today about a cost-effective method to remove paint and powder from your hooks and racks without destroying them. So we'll discuss the evolution of paint stripping and how it's changed throughout the years. We're going to discuss the hook and rack stripping methods and the pros and cons of each of these methods. We'll spend a little time on the inline paint stripping process, and then we'll discuss a couple of case studies. Okay. Sorry about that, Joe. Sorry about that. There was a technical issue there. Why do we clean hooks and racks? Number one is to prevent paint and powder defects. This is one of the number 1 reasons for paint defects in the process is poor contact and poor electrical conductivity on the hooks and racks. We want to ensure that we can provide consistent electrical current to our racks and get a good surface. We want to ensure that there's good part to rack contact. We do this by cleaning this. You don't want part to paint or part to powder contact. You want part to rack. This also, the cleaning hooks and racks ensures rack longevity. And it also provides process consistency. If you have a clean hook and rack, you don't have to worry about the that part of your process. You will get a consistent process by having clean hooks and racks. The evolution of paint stripping. To start with, it was using some sort of abrasive method, a brush, sandpaper, hammers, channel locks, or sandblasting. You use some type of media or tool to break or remove the powder and paint from the surface of the rack. It was a very labor-intensive process. So people started looking for different ways to do this and batch processing. So it leads us to the thermal processes, burn-off ovens, fluidized sand beds, molten salt, the actual flame. You burn or melt the coating off the surface of the part. It's effective, but it requires subsequent cleaning processes afterwards, and it typically damages these hooks or racks. Repeated exposure, heat and cold, causes thermal stress and can damage these parts. Then we started looking at organic solvents, things such as methylene chloride come to mind. While these are extremely effective, they work on all paint types and substrates. They're highly regulated. They're carcinogenic, they cause cancer, and they're expensive. So we had to find a different method to do this. There There are methods to use paint strippers, such as high caustic paint strippers. These are very effective. They remove paint, liquid paints, e-coats, powder coats. However, if you use a high caustic paint stripper, you have to understand you can't put an aluminum part or a soft metal part in that solution or you will destroy it. So to combat that problem, they designed mild acidic or neutral paint strippers. Some of these are less effective because they're weaker, but many of these are very effective. However, if you're using an acidic paint stripper, you really don't want to be stripping steel parts. You can attack the steel and it depletes the chemistry and shortens that bath life. So you have to determine if you're using mixed metal, if you want to focus on high caustic pH or mild acidic strippers. And finally, they developed thixotropic or thickened paint strippers or gel paint strippers that you can apply to the surface of a large bulk storage tank or an airplane wing. And these work by applying the thixotropic paint stripper to the surface and allow it to clean and sit there for 4, 5, 6, maybe even 24 hours. Then you come back and you spray this paint stripper off of the surface that are with a high pressure wand, and you collect the paint stripper and the residual paint that's removed from the surface of that part and dispose of it. Problem with that type of paint stripper, you can only use it one time. It's one-time use in time, so it's fairly expensive, but it may be your only option to remove paint or powder from a large surface. Next, we're going to talk about the hook and rack stripping methods designed specifically for hook and rack stripping. Physical removal, sandblasting, burn-off ovens, offline, inline, and high temperature salt. All of these are methods that are being used today to remove paint and powder from hooks and racks. We're going to talk about the pros and cons of each one individually. Physical removal, it's exactly what it sounds like. I've walked into many shops and seen somebody standing at a table with a pair of goggles on, holding a part or a hook with channel locks and hitting it with a hammer and breaking the paint off of this. It's not safe. It's very time consuming. The effectiveness is not as good as paint stripping or burn, but it works for some smaller operations. There are better methods. So the one thing that I really want to point out here, if you choose to do this method, you must have an excess inventory of hooks or racks to keep your process running while you're cleaning your hooks and racks with this method. Sandblasting is a method that is used to, it's much more efficient than physical removal. It's a small capital expense, allows you to clean the parts effectively, but you can only do one part at a time. It can be very labor intensive, and it can be destructive to your substrates. If it's a soft substrate like aluminum, or if it's a soft, it has some plastic parts on your rack, you'd have to be very careful not to destroy those parts. And if you're going to choose this method, you must have an excess, another set of hooks and racks to keep your process running. But this is embarrassing. I apologize. Okay.
It won't advance on you, Larry?
It will not advance.
Okay. Let me see if I can pull
Apologize,
it up.
everyone. All you can see is me.
We can see your pros and cons of sandblasting. So if you want to keep talking there, I can see if I can share my screen with it and see if that helps at all.
Apologize, Kelly, if you can do that.
Let's see. Get that going here.
Okay, next screen.
All right, is that the,
That's the sandblasting.
all righty. Just want to get the rest out here. Okay,
That's the next screen. There we go. Thank you.
all right.
And again, move ahead and persevere. I apologize again for this delay, but the next process we want to talk about is burn-off oven. And this gets into process efficiency. This is a much more efficient process. It allows you to clean and process more than one batch processing. You can do more than one part at a time. You load your hooks and racks onto a carrier, push them into the oven, close the doors, come back 4 or 5 hours later, pull them out, and then you have to clean the residual hook, the ash or residue off the surface of the part. It is much more efficient, but the repeated heating and cooling of a part is damaging to the racks over time, makes the wells very weak. You do have to have a subsequent cleaning process to remove this oxide or ash from the surface of the part in order to keep from contaminating your pre-paint process or paint and powder process later on. And if you choose to do this operation while you're cooking or burning off the actual paint or powder, you must have another set of hooks and racks to keep your process going. So next slide. Next, we'll talk about what we call offline chemical paint stripping. It could be in-house, it could be in another area outside of your paint or powder operation, or it could be off-site. You could actually pay a vendor to do this. Some pros, again, you can do many parts at one time. You're limited by the size of your tank, by the number of parts that you can put in. The pros, there is no metal fatigue. You choose the right paint stripping solution, you put the parts in, immerse them into this heated solution, come back 20 to 30, maybe an hour later. It usually takes between 15 to 20 minutes per layer to remove, to clean the paint and powder from the surface of the part. But when you pull it out, the part is clean, you rinse it, it can go immediately back to your process. Some of the cons, like we discussed earlier, you're going to have to choose the proper solution. If you've got mixed metals, you have to use a certain solution. If you've got all steel, you use an alkaline solution. If you've got soft metals, such as aluminum, you must use something on the acidic side. And another con, when we get into chemical paint stripping, you must be cognizant that you need to remove your waste. You have to treat your wastewater. And that's, while it's quite possible to do, it's easily waste treatable. You now have to do that. That's part of your process. And if you choose this type of operation while you're waiting on your parts to be stripped or cleaned, you must have another set of hooks and racks to keep your process going. Next slide. Then there are the high temperature baths, like your fluidized sand and molten salt. Pros, very efficient process. It cleans very quickly. It burns off very well. It leaves a good clean surface. It's effective on all paint types. And however, you must have a cooling period. You can't, when you pull a part out of an 800-degree plus, be up to 1,000 degrees, you pull that part out, you can't just hit it with cold water. You're going to destroy the rack. It's going to warp, it's going to make the wells weak, and it expedites your metal fatigue. So you must wait for the parts to cool before you can clean them. And you do have to remove the residual salt. You do have to remove the residual sand to keep from contaminating your other parts. Next slide. Which leads us to the inline chemical paint stripping process. We feel like this is the most efficient option. However, there are limits here. The number one limiting factor is space. You must have the space to put a tank at the end of your powder coating operation or your paint operation. The tank would go online after the parts are removed from your hooks or racks. You would leave the hooks or racks on the conveyor. They would travel through this tank, and it's determined on how long it takes to strip one layer of paint or powder from your hook or rack. Typically, it's in that 5 to 10 minute range. You choose a solution that can remove it in that 5 to 10 minute range. If you're 5 minutes to remove the powder coat, your line speed's moving at 10 feet per minute, you're going to have a 50-foot long tank. Sounds fairly large, but if you have room at the end of your tank, the efficiencies more than make up for this. There's no metal fatigue. There's no loss of conductivity. Parts are clean, the same level of cleanliness every time. When your racks go back into the pre-paint operation, they have the exact same level of cleanliness every time. So you don't have to worry about if they're part contact with the rack, is there going to be good electrical conductivity. That process inefficiencies are removed. That variable's removed. You're not dependent on any vendors or even other areas of your facility to keep your rack in operation. You don't need that. And there's no waiting for cool down. But the cons is it's fairly expensive. You've got a large piece of equipment at the end of a process line, and you've got to have room. You're still going to have wastewater treatment issues, which can be compensated for, but you do need to be aware of that. So, next slide. Which leads us to case studies. The first case study I want to talk about, this customer needed a better way to clean their hooks and racks. They were spending a tremendous amount of money on rack repairs and cleaning, and they needed a more efficient method to do this to make them more competitive. Next slide. Okay. Some of the pain points with this customer. Number one, metal fatigue. They were spending greater than $300,000 a year in rack repairs. That's what led them to choose a different option. They were using a fluidized sand bed before, and it was very effective, but they were having constant problems with rack repairs. The process was causing their wells to fail and their racks to break and cause defects in the line. So they're always spending a lot of money and time in rack repairs. They had a cool down required afterwards to compensate for this. Just because it cleaned the part in 5 minutes, they still had to wait 30 to 45 minutes for the racks to cool before they could be handled and cleaned and go back into the process. They had 3 sets of racks, one set of racks being cleaned, one set of racks being repaired, and one set of racks in the process. So they had a tremendous amount of racks in this facility. And they actually determined that the place where they stored the racks is where they were going to put their inline process tank. They paid 3 full-time people just to handle the racks and the rack cleaning process. these people were responsible for the rack cleaning operation, and it's 3 full-time people. They also, if they had any shutdowns or maintenance required to do on this tank, it took 2 to 3 days to shut it down, to cool it enough to work on it, replace the sand, clean out and do any maintenance on this tank. It took 2 to 3 days. They also had examples of power outages. When they had several power outages in this area, and when power outages came, racks were trapped in the fluidized sand bed, and by the time the power came back on, the racks were destroyed. And just the physical demands of handling these racks, the operator was required to inspect the rack before loading it apart. If it needed to be changed, they picked the rack up, carried it over to a carrier, replaced it with a clean rack, and just the pinched fingers, cuts, twisted backs, just issues like that. They measured this when they made the decision to go to an inline process. So when we switched to the inline process, these were the results. They were able to reduce the labor to 1 full-time person. This one person was a shift mechanic who spent 15 minutes of each morning at the beginning of their shift, and they analyzed the bath, made any adjustments necessary, and kept the process running. There was an 83% reduction in rack repair costs. They still had to replace spring steels and such on the clip that held the parts, but there were no issues with broken wells and damaged warped racks, and that was eliminated. There was a 90% reduction in potential near misses. Again, this customer, when they had just one example of the near misses that they pointed out, when they would put parts into this fluidized sand bed, it would create smoke and sometimes small flames and set off smoke detector or fire alarms. There's 500 people that worked in this facility. So you had 500 people that had to assemble at their assembly points and wait 15 to 20 minutes for the all clear to go back in. That's a big number for this company. There was a 30% reduction in real-time accidents. Now that's plant-wide. There's a 100% reduction due to rack-related injuries, back problems, hurt back, cuts, burns. All of those were eliminated. The strip time was reduced to 15 minutes real time from the time the parts were offloaded from the rack, went through the strip operation and returned back into the pre-paint process was 15 minutes. And just the improved ergonomics, there was just less handling. There was no more inspections, no more defects due to buildup of paint. And all of this resulted in a $330,000 a year annual savings. Was a great success with the customer. Case study number 2, a wheel stripping operation was struggling to keep up. This wheel manufacturer had 2 large burn-off ovens that heated to 800 degrees. Each oven held 36 wheels, so they could run 72 wheels at a time, cook these wheels for 4 hours, allow the parts to cool for 1 hour, and then you would have to clean the parts. They chose a wheel abrade, a sandblast cabinet that held 5 wheels. It's called a paintborn. I apologize. And all of this resulted in being able to process 72 wheels in roughly an 8-hour period. One of the bottlenecks here is the fact that this paintborn operator received 72 wheels all at one time, and there was a huge bottleneck there that he was struggling to keep up with. Next slide. This is a process that we used here. This is our pilot line, but it demonstrates the process that we use for this customer. Just immerse the wheel in the solution for 20 minutes, pull it out in just a moment, and you'll see that it's clean. And all we had to do is just a quick water rinse. The paint stripper is water miscible, and you rinse it easily. That's how simple this process was. Next slide. So some of the pain points they were experiencing low capacity. I mean, it's large machines, but they could only do 72 wheels per 8 hours. Very long processing times, cooling times, and bottlenecks. So the outcome, when we switched to a paint stripping solution, we went to a much smaller operation. You're limited by the size of your tank. We mentioned earlier with an offline process. This customer, we built a tank that would hold 10 wheels. It held 10 wheels, but you only took 20 minutes to strip the wheels. So we're getting 30 wheels every hour that would be sent to the subsequent operations, or the paint stripper. I'm sorry, the sandblast cabinet. And this is where the bottleneck was at. He was receiving 30 wheels per hour. That's 240 wheels in an 8-hour period. And this sandblast cabinet, where he's receiving 10 wheels every 20 minutes, it only takes him 5 minutes per load. He's staying ahead of the operation. They no longer have that bottleneck occurring. So it's a much more streamlined operation. And they were able to eliminate 308 hours of downtime annually. That's what they calculated. Now, their number, when we started this investigation, they were spending $7 per wheel to run this operation, which was very cost prohibitive. We cut that in half. We guaranteed to cut that in half to $3.50 per wheel. After we improved efficiencies, it was below $3 a wheel when we finished this operation. So we increased production 76%. We went from 72 wheels per day to 240 wheels per day, and did this with a $43,000 a year annual savings, showing that this was a very cost-effective method. Now, again, I apologize tremendously for the technical issues. And I thank Kelly for helping me and being patient. I hope I was able to help you and get you some information that you can use in your process today.
All right, if anybody has any questions, please go ahead and start typing them into the question box there, and we'll start going through them. I do have one that came in, Larry, on that last example. What is the annual cost of the chemical stripper for that wheel stripping example that you were talking about?
Wheel stripping operation, it's going to be dependent on the number of wheels and the part orientation. They were spending roughly $85,000 a year in chemistry.
But the annual savings was including that amount.
$43,000 based on what they were spending before.
Okay. Was there any OSHA regulations that had to be accounted for when they changed to the chemical stripping?
Those regulations, we're talking about manpower, or it depends. We do address and acknowledge the fact that if you're doing chemical paint stripping, we have to do waste treatment of the rinse waters. Our goal is to never dump the paint stripper. And I apologize, we didn't even touch on that. You can make these paint stripping baths last indefinitely if we do proper maintenance. Remove the residual paint sludge real time with filtration or centrifuge filtration, some method to keep the paint out of solution or the powder out of solution. And then from routine maintenance, 2 to 3 times per year, remove the paint sludge and check your equipment. But you make that bath last indefinitely. We don't want to dump the paint stripper for no reason. We want to make it last. And in fact, the plumbing manufacturer we talked about earlier, that bath was 7 years old. We never dumped it. We would do maintenance, put the paint stripper back in, bring the solution back up to the working level, and continue to operate. We did have to treat the wastewaters, and that's easily done. We have there are chemistries to remove any, if it's alkalinity, it's usually simply a filtration and adjust the pH. If this is acid, it's the same other scale, adjust the pH up, remove, filter the residual paint from the solution, and waste treat that rinse water. There are some solvents that require different waste treatment, but we have the ability to do so, and it can be done cost effectively.
Does anything from like a PPE or a containment or anything like that that has to be added?
Yeah, thank you. Yes, I would always suggest ventilation. Typically, it's not so much the chemistries that you're concerned about, it's the fact that we operate at temperatures that generate condensation in water. So you always want ventilation to remove that moisture from your plant. You don't want to have a rainforest inside of your plant and have condensation dripping in other areas. I would suggest ventilation. I would, because of the heat, I would recommend goggles, gloves, and a rubber apron to protect. It's typically for the heat. The chemistry, if we're using a high alkaline solution, it would be gloves and goggles, just because you don't want to get that in your eyes. But it's no different than handling any other of the chemical processes in your plant. Your alkaline cleaners typically just it has about the same hazard class.
Besides powder coating, will this work on like caulk and water-based and auto paints and things like that too?
Yes, we would. I mentioned earlier, your paint stripping solution that you would choose would be dependent on the type of. But paint strippers, there are paint strippers that are effective on caulk. I've got several customers removing caulk coatings from hooks and racks effectively. Wet paints, e-coats, powder coats. Some of the, powder coats are becoming better every day, and the goal is to make them hard to remove. You want them to last, but we have found effective methods to chemically strip all the coatings so far. The hardest probably being PVD. Those you have to have some sort of physical method prior to it, but then the chemical paint stripping that solution, it is quite possible to do that.
Okay. In reference to the 10-minute soak time, is this all done in just a tank as a vertical, or is this in a continuous? I mean, what method can this be applied with?
It depends. We talk to our customers. You build the tank, you design the tank to fit the number of racks that you need to strip in a certain amount of time. If it's an offline process, if we're going to move this to another area of the plant and we have an immersion tank with a paint stripper in it and a rinse tank beside it, you want to build that tank large enough to be able to strip your racks in the time frame to keep your process running. If it takes an hour to strip 20 racks and you need you need 60 racks per hour, and it takes you an hour to strip, you need to build that tank large enough to hold 60 racks. But that's just even math. I mean, it depends on the number of layers of paint. Like I said, it's 15 to 20 minutes per layer, typical on an offline process. If you're doing the inline process, you need to be able to you need to be able to send your part, hook, or rack through that tank. Where we try to use heat, immersion, and solution movement with like eductors underneath the solution to shorten that process as much as possible. I've had it as low as 5 and as high as 15. It just depends on that topic. And then we have to build the tank long enough to strip the part and strip one layer of paint and transfer time of that tank. It could be 100 foot long. I mean, it just depends on how big your parts are and how fast your line speed is.
Is there a relationship between the cost of the chemical solutions, related to removing the paint versus the cost of running a burn-off oven?
The biggest issue with the burn-off oven, you have swings in energy cost, and typically burn-off ovens are gas-fired. There are times when it's a very efficient process cost-wise, but you get out, there are different costs that we try to, the cost of the chemistry and the cost of the burn-off process are typically similar. Once you have the paint stripping solution in the tank, it's very similar to operate, but the plus of using the chemical paint stripping method, you don't have to worry about the damaging effects of a burn-off oven. burn off oven, over time, you have metal fatigue, and it does destroy racks over time. And you also have a subsequent cleaning process of some sort of high pressure wand cleaner, something to remove that ash residue. That's part of the cost that we're competing against. You do not have that with an offline process. You need to pull the parts out of the paint stripper. You saw the wheel was clean. You just rinse it and use it. It should be the same way with your racks.
What kind of temperature do you need to run the bath at, and is agitation required?
Temperature runs anywhere from 120 to 200. It depends on the paint, powders, and solution we're using. You're stripping a real durable epoxy hybrid powder coat that's designed to last for you. It may take 200 degrees and 30 minutes to strip that. But we would design the process to fit your needs. You find the right paint stripper to shorten that process as much as possible. And yes, agitation is required. Typically, these solutions require, the agitation is advantageous for two reasons. It keeps it a homogeneous single solution, because at times some of these paint strippers will split and do multiple layers if they're just sitting idle. The agitation also, if you return this back to eductors, it creates impingement at the surface of the part and shortens the strip process. And that circulation can go through filter bags and remove the paint real time. There are multiple advantages for using agitation.
Okay. You mentioned about removing the paint and with filters and filter media and all that, or from the sludge. What type of filters are they that you'd have to use, or is that part of the system always? Very few of these are just off-the-shelf paint stripping operations. Most of these are specially built tanks. If you're going to use filter bags, I would recommend stainless steel housings, because we're using a heated solution. And you're not going to remove the pigment from the paint stripping solution, but you do want to remove large pieces of paint to get that out of the solution real time. I'm recommending like 100 microns on a filter bag to remove paint and catch large parts. And then from time to time, if you use a filter bag, you're going to have to do a shutdown and decant the paint stripping solution from the surface from the top of the tank and get the sludge out. Put your paint stripper back in, and we adjust the parameters of the bath and continue running. If you customers have used centrifuge filtration, real-time centrifuge, it removes the particulate real time as it's circulated through a centrifuge and returned back to the paint stripping tank clean. Those are very effective methods. It reduces process swings, strip times, and keeps your process very consistent. It also reduces the maintenance required on the tank. And it may be as simple as, I've had customers that just have a screen in the bottom of their tank, and at the end of the day, they stop their process. They allow they allow this material to settle. They pull the screen up at the beginning of the next day, and they dump that sludge that's accumulated in the bottom of it. There are multiple ways to do this. We can make it as labor, it reduces as much labor as possible with pumps, centrifuges, and filter bags. But you may have, if it's a small tank and you don't have that ability, you are at the very least going to have to do decants and get the sludge out of the bottom of that tank to make it last. Has this ever been used in an aerospace application?
We have aerospace suppliers that use paint strippers to clean racks, certain parts. I mean, honestly, the aluminum parts, the aerospace industries and the surfaces of the part would lend themselves to paint stripping more than they would the burn off. You couldn't do the burn off. You couldn't do the sandblasting because you got dimensional changes. Chemical paint stripping is effective on aerospace parts.
Okay.
The hooks and racks, I will mention to you now, the hooks and racks, the titanium racks are very prevalent in this process. I found this over the years. They spend the money up front on titanium racks. Titanium racks do not show the metal fatigue that we're talking about with steel racks or other racks. So the burn off that fluidized sand bed is a good process for the rack cleaning operation in an aerospace industry. But the parts for rack for aerospace would lend themselves to chemical paint stripping.
Okay. Can you explain maybe a little bit more on the process parameters that you use to maintain the paint stripper?
It's typically, there's an acid-base titration to measure the alkalinity or acidity of the bath, and a solvent split where you measure the solvent portion of the paint stripper, and we control those two variables, and you make your additions based on whether it needs solvent or some sort of either acid or alkaline adjustment.
Okay.
And water. I mean, honestly, you may do the titration and find that your concentration's over 100%, which means all we've done is driven off water. We just add water.
Okay. Can you explain a little bit better, and maybe what's available for just a small powder coater that does not have an inline conveyor system? What could they do?
I mean, it depends. Again, it depends on how big that. When we say small powder coaters, some of those have a tremendous amount of hooks or rack, and it may lend themselves to actually look at an offline process with a tank, an immersion tank. But I don't want to dissuade. There are many customers out there that use small processes, and we have paint strippers that you run them until they die. To be honest with you, that's what happens. That customer may buy a 5-gallon or a 15-gallon solution of this material and just sit their hooks in it at room temperature overnight, come back, rinse them off, and use them. That may be their method, and it's good enough. That keeps their operation running. But once that paint stripper stops working, they don't really have the ability to extend that bath life. You have to seal the container and have it disposed of and open a new one. Now, I'm not saying you do that every batch. That paint stripper would last longer than that. But smaller operations, that's quite prevalent. Many people do that, and it's effective. It's much safer than having a customer has to physically sandblast or rip and beat the paint off of a hook or rack. It's much more effective than that.
So, and you mentioned that you don't necessarily have to dump the bath and recharge it, but does it have to eventually be done, or is it a matter of what filtration systems are put in place?
Of your bath maintenance. If you take the time to maintain the bath, filter, keep the paint out of the solution, do routine maintenance, and get the sludge out of the bottom of that tank, they last indefinitely. Now, if you drag some contaminants in, let's say you've got an alkaline paint stripper and you drag an acid in, you neutralize it, I really can't, there's not a lot I can do there. You'd have to dump that bath. If you do so, you would have to pump that solution into containers and have it disposed of, because I don't know what's in your paint or powder. Some of those contain metals, and and whatever the contaminant is, you would have to have that disposed of. It would be very hard to waste treat a paint stripping solution, a large 2,000 gallons of paint stripper into your waste treatment operation would be a nightmare.
Okay. Do you have to, then I'm assuming you have to top off the paint stripper every so often, the chemical, just like you do in a pre-treatment washer?
Have to replenish what is carried out on your part. That's the biggest use of chemistry. The surface area of parts, hooks, and racks going through that solution is 95% of your chemical usage.
Okay.
So we tell customers to design racks that don't have that are solid instead of hollow racks. But the square bar, solid steel racks versus the square bars that would hold a lot of solution and drag a lot of solution out. We suggest customers designing the racks up front to keep from carrying out excess chemistry. That's where most of your usage would be.
Okay. There was one question back on the wheel example. Specifically, how did you handle the wheels to get more production by 76%? Could you go back over that a little?
Again, this customer had 2 ovens that could process 76 wheels per day. 72 wheels per day, 36 wheels per oven. So when we went to a smaller tank doing 10 wheels per load, that customer was able to strip the wheels chemically in 20 minutes. So every 20 minutes, he was getting 10 wheels or 30 wheels an hour out. And that resulted in 240 wheels per 8-hour period versus 72 wheels per 8-hour period. And you didn't have that huge bottleneck coming to this customer, to the sandblast operation at one time. That sandblaster, he would see 72 wheels and he could only do 5 at a time. Okay, he's got a good 2 hours of work in front of him where he could get 10 wheels at a time and stay ahead of the operation. They never had that bottleneck. Now, the reason they had to use the sandblast after the paint stripper was these were rework wheels and there were rubber would get on the parts on the wheels, and you had to have a blast operation to remove that rubber. The paint stripper didn't take the rubber. They were very pleased with that operation.
Is this
did that answer that question?
Yeah, I think so. Is this the paint stripper and all that? Is that approved by various OEMs? You know, anything like GE, Rolls-Royce, GM? You know, any of the big, the typical OEMs?
I don't know of any automotive specs per se that we typically supply the tier 2 and tier 3 suppliers, and rack stripping. You know, I don't know of any specs that are. I've never been asked for a automotive spec for this paint stripping. Now, if they were stripping parts, that would be a different question. It is possible to strip and rework parts. I do that in the rework industry, and I've still not been asked for a spec. Does this mean a spec? It just has to have a, because they're water missing, is typically not an issue as long as I don't carry it down the subsequent processes.
Okay. For testing the chemicals in that, is that a titration, or how do you check your current levels in the stripping tank?
Titration is more accurate. I've got customers that use dropper bottle test methods. I mean, you've got a 5% window either way to keep a good consistent process. So a dropper bottle method is good. Titrations are best. If the customer is large enough and has the ability, they could design an auto titration process on the tank to make additions. I mean, it can be as automated as you want to spend money.
Okay.
It's just a simple acid-based titration. You can make it very effective. We could not do the solvent split. That way, the only way to do that measurement is to pull a sample, dilute with water, and 100 ml volumetric, graduated cylinder, and then allow it to separate and read that number.
Okay. Last one, I don't know if, I think the last question we have here might be a little bit more technical, but is this paint stripper a biphase with an oil seal layer to prevent evaporation of the chemical?
Those are predominant. I mean, again, we mentioned we have to choose the right paint stripper. If we're looking at an alkaline paint stripper, those are typically biphasic. Once you pump that solution into the tank and it becomes contaminated and you heat it, when you cool it back down, it splits into multiple phases. That's the reason we have to use agitation. It forms a suspension, not a solution. And once you mix it, you have agitation going and you hold it in solution, it's very effective. But if you stop the agitation or movement, it splits into 2 phases. Same thing with some of the acidic paint strippers. There are solvents based on NNP and certain amines that hold a single phase, but those are the ones that you would typically want to put an oil phase on the surface of to keep, because there are odors. I mean, I can't get over the fact that I can't hide the fact that those parts smell. So we typically put an oil blanket on the surface of those type paint strippers, number one, to limit evaporation, and number two, to limit smell. So there are functions there, and we try to choose the best paint stripper for each customer. We're very upfront with them. If they're running mixed metals, where you've got a part that has steel and aluminum components, I can't strip it in you've got to go to something like an NNP-based paint stripper to keep from attacking and destroying that part. So that's the limitations of chemical paint stripping.
Okay. Well, that was the last of the questions. So thank you, Larry, very much. I just want to let everybody know that we do have the Powder Coated Tough magazine, both in English and in Spanish now. Yeah, it's a free subscription at powdercoatedtough.com. It covers all different aspects, including paint stripping. We have different things. If there are any questions that come up, you have my email now on the screen. Feel free to email me. I'll get them over to Larry, and we will get them answered back to you as quick as we can. But again, I would like to thank you, Larry, and thank everyone for attending this webinar. Apologize for some of the technical difficulties that we had in the beginning, but we were able to get through it all. And also remind everybody, if you go to our website, powdercoating.org, for more webinars and training events that are there. We'll be conducting a Spanish webinar next month on the fundamentals of powder coating, so be sure to check it out. And if you have any Spanish speakers in your organization, please pass it along to them. Otherwise, just remind everyone, watch for the link to the survey that will come up right as we close here. Just take a few minutes to give us your feedback. And with that, I'd like to wish everybody a happy and a great day. Thank you.
Thank you.